Hello all together. First I want to say thank you for about 230 subscribers. I can't believe that so many people watch and subscribe, but it's nice. Thank you. So, what today? I get out an older project. It is from October 2015, so 2 years ago. And 1 week ago, I was a little bit surprised to see a special video or see a video in Dave Jones' EEV blog where he's showing module DPS3003. And I think, oh, I know this module. I get it earlier. Okay, I get another one. I get one of the first batches maybe. It has also a little bit different name, but it do the same. It's a little power supply module where you can set up voltage, where you can set up amps, and it is also constant current and constant voltage. So he do a lot of measurements. He show things on the oscilloscope and explain those what he measure, and it comes out the module is not bad. I used the module 2 years ago, so I'm very happy with this. 2015 I make a project in Instructables for it. It was quite successful. It has also a lot of views, and it get I don't forget the name what they say it. I get a prize for it, or I don't know. Doesn't matter. This is the product I built. I didn't use an off-the-shelf plastic case. I built my own case for it out of wood. Like my other projects, all in the same style, the 4mm plywood with the brown finish. So this is one of the earlier models I built in this thing, and this is the model I used. Okay, it's should better prepared. Sorry. Maybe this is better. I used the RuiDeng, keine Ahnung how to say it. DP20V2A. It was for 20 volt, 2 amps. Power supply module CNC. I don't know why they say it's CNC programmable constant voltage current. That was the name they used 2015. And it doesn't have the new nice interface. It has only this interface. It doesn't switch to the other interface Dave Jones show. He has the DPS3003 module. I think I already see them. I already can buy them. But I'm still happy with my one. And now I show you the product I built, or the thing I built. I don't wonder about some cables hanging out. I just prepare for something for the video. Okay. So by the way, all the links for the things and the project in Instructables I put in the links down below. So should be some advertisement. I only have advertisement biros. Maybe it's because of my work. So yeah, here comes the thing. My portable. Yeah, it's portable. It doesn't need main voltage. It is using a lithium-ion battery pack out of an old laptop, and this is already a new one. The first design have a 4-cell in series design. Now I have a 6-cell design with 3 in series and 2 in parallel. Maybe here you can see the battery management system for balancing and loading. And in this corner we have a step-up converter, a DC-DC step-up converter. And the cables running out of here is to measure the amps. Later I want to show you also the efficiency. I don't make it like Dave Jones with a list of hundreds of measurements. I only make it with 5 to 7 measurements. There's a switch to switch it on and the charging port. For the charging port I also built a cable. It's here. Yeah, the colors are different. It's blue and yellow instead of black and red, but yellow is plus, blue is minus. I charge it with 12.6 volt and has this little nice connector. Even as 4 pins, 2 pins more than I need. So why I build it? Yes, I build it to not only use electronic in my room here, also on travel or on other things, because this is portable, only need to be charged up, and it doesn't make any noise. You know, I already have, or I guess I have problems with my light in the room when I make videos, so I'm trying things with lights. I try LED lights like this one. And the problem is that my power supply, my bench power supply, has a very noisy fan inside, but this doesn't have any fans. So after I switch it on, put it here, wait, I put something underneath so you can see it a little bit better. And you see here I have 19.9 volt input because of the step-up converter. I can plug in the LED lights, set the voltage about, how much I use, 10.5 should be enough, and the light goes on, and I can use it to show you more like this or just blind you. So it doesn't make any noise. I'm drawing about 660 milliamp and 7 watt. I think I can even get more out of these LEDs, but that is enough. It has a good cooling. Okay, now I bring in the meters. I set up the measurements, and then we measure and see how efficiency it is even with the step-up converter. I didn't think that it's better than 70%, but it's okay. I have a very beefy power pack inside. It should keep long enough. So just wait a moment. I set up the measurement and arrange the table. I need more place for it. So the setup is finished. You see I still have problems with the light, so forgive please that the light is not the best. What did I set up? Here, out of the view, on the bench is the electronic load. Then here is the portable power supply with the DP module. Here is the Unity UT61E to measure the input voltage. It is now about 11.8 volt, so the battery pack is not fully charged. And this is the amp meter for the input. And only the switched on module with the DC-DC converter, step-up converter, already draw about 64 milliamp. So don't forget to switch it off when you don't use. You're already wasting 64 milliamp. I'm not sure if I should guess this in the efficiency, but I will. Then on the output we have the voltage on the Benning MMP3 and the amps on the AN8002. The output is not, it's no load yet. It's not switched on. It is switched on. Yes. You didn't see this. I measure AC voltage on this. I'm so used now to meters that switch automatic between AC and DC. So sorry for this. Okay, now it shows 5 volt, of course, because I switched on the power supply, the output to the power supply. But I didn't get any amps now because there's no load on the output. But so I can already write down without load. No, makes nothing sense. I set it to 2 amps, the load, about 2 amps, because I use this to power up Raspberry Pis. Play around with a Raspberry Pi and a screen, very useful for this. So my first measurement will be for an output voltage about set up to 5 volt. It goes down when it draws some amps to 4.96 at 1.943 amps, and the input is 11.57, it's enough, and 1.11 amp. So bring in the calculator. 11 point, maybe I should go through the measurements before the meters run out of battery, especially this one. The calculation I can make later a little bit bigger, so I just write down. So I should get higher voltage. Yes, so I press on set. Another one I often use, switch off. Another one I often use is about 12 volt because of the LED screens or the LCD screens I have. So I set up to 12 volt, also at 2 amps. So I want to see how it perform at the higher end or at the with more load. So now we are on 12 volt, about 12 volt and about 2 amps again. So on the input we have now 11.24 4 it goes down because of more load. We have about 2.67 amps on the input, and on the output we have 11.95 at 1.944. 944, not 9. 9 is German, I have to remember. So I just put down the electronic load now to 1 amp, about 1 amp. It's not so precise, and I have to turn. I don't have the fancy loads other people use. You know who I mean. Yes, even this fan is from the load, so doesn't wonder, it's not from the power supply. Now at 12 volt and 1 amp, about 1 amp plus minus, I'm drawing in the input 11.44. You see the voltage already get up because the batteries recover. I'm taking about 1.25 amps, and on the output I'll still have a little bit more because it doesn't drop so much, 11.98 at 0.98 amps. So the last measurement, I will use the full load, full amps, and wrong direction. Or maybe I get a little bit more than 2 now. Because I did 2, otherwise it just break. That is a little bit too much. Doesn't matter. Nothing should broke. So 2 amps, and the output voltage of this module I will set to the maximum I can get, because remember I'm using the stepper converter, so set to 19, so I don't think that I can get the 20 volt out. I can get out 17 volt. That is the highest I can get out. So on the input, my input voltage dropped down to 10.87. The amps is already 4.2 amps. Yeah, that's a lot. The output voltage is 70.01, and the output current is about 196. That is, yeah, still good. So I should pause again, bring away the meter stuff, zoom in the little settle, and then calculate for you the efficiency. I make this first, and then it takes a while. You don't need to see me typing in it in the computer. So see you back. Yes, this is the result. And I'm surprised. It's better than I thought. I thought it will be under 70%, like I think I mentioned in the beginning, because I'm using the DC-DC step-up converter, stepping up my maximum of 12.6 to about 20, and then I'm stepping it down. And so I thought it will be under 70%, but it is in every circumstance, in every of the 4 measurements, it's over 70%. And here it's already 82%. That is really not bad. It's the case where I'm using 12 volt at 1 amp. So that is not bad. This is very low because I think I step it up, I step it down to very low value, and I'm using 2 amps. Like here also, when I use 2 amps, I have the lowest efficiencies. What I'm thinking about now, after I do this and see the video from Dave Jones, the original module is good at efficiency. I want to switch to bypass the DC-DC converter. So if I need, for example, only 5 volt at the output, or maybe 8 volt, 9 volt at the output, I will bypass the DC-DC converter. So I have get rid of the efficiency of the DC-DC converter. So I have more efficiency because the DC-DC converter doesn't matter. It is just out of the circuit. So I have thinking about, because it's not done with a simple switch, so because the DC-DC converter is between the circuit, and I'm not sure if the DC-DC converter, how often I say DC-DC, I'm not sure if the DC-DC converter like it when I feed voltage or feed energy on backwards into it on the output. So I won't do this. Maybe I should check it out if it draws some amps or not. That is maybe a way I can do it. Yes, you see, I'm thinking about already how to do it. Okay, thanks for watching. Thanks for 230 subscribers. I'm really impressed of it. Can't believe, I think it's already 235. Yes, that's great. And yeah, that's all for this video. The links to the products, I think I put everything. No, I only put the DP20V2A something in, and the newer modules I get. Because when you buy from Banggood, when you buy from the links, I get a little bit amount back when I can use for my hobby to buy new interesting products. And maybe I can make it and find an interesting product before Dave Jones. But I think this product, the module, now becomes more popular because he found it, and that's the reason I make this video. Of course, I want more clicks. I want that more people find me, more people watch my video. Even I'm really worse in making videos, but it's still fun and it's hobby. I make electronic. I like to make things in electronic with electronic, and if I can make some videos, I also like it. So thanks for watching. See you next time. Maybe I should start Patreon. Maybe someone will be my Patreon. I have no idea. Okay, bye bye. How often I say bye bye?